Parts 3 and 4 of the plasma adventure. Hooking our plasma up to air and power and actually cutting something with it. Stand by. Hey everybody, welcome back to RATTLECAN FAB SHOP. I'm James, and we are continuing on with parts 3 and 4 of our PrimeWeld CUT 60, dual video playlist appearance event. Throw in whatever adjectives you would like. So what I have is, we have our unit connected up to power. We also have affixated the appropriate fittings because I have heard tales of horrible cut quality because of wet air. So my compressor, which is conveniently located right close to where we're working, I do have a spitter valve that operates every 43 minutes. I also have an air dryer right outside of the tank that I empty out every time I get to using this thing. I also have a dump valve on one end of my run so I can get any accumulated moisture out of there. I also have another dump valve way over on the other end of the shop that I dump that out of. And we are going to affixate this air dryer from the end of our hose into our unit. This is a temporary solution right here because one of the things that I am not totally jazzed about is the inlet for your air is way down low, and if you are going to connect up a filter like this, well, it just happens to hang down below the level of the feet. So you kind of have to hang it off the back of the unit. This is not going to be a permanent installation where it's at right now, so this will do for us getting by temporarily. So let me get that hooked up and then we'll continue getting things ready to go here. All right, we've only got a couple of things that we need to get attached here on the front. One is what they call our workpiece lead. And again, most of us would call this a ground. This is a DINS connector. There is a tab on the top. There is a notch on the top. You twist and you insert. You don't have to gorilla it, but it does need to be firmly affixated. The other thing we're going to do is we are now going to remove our protective cap from our Au.Ra central connector. And again, tab to the top, notch to the top. You just push it in, screw. Not gorilla tight, but tight enough. So what I'm going to do, because we're going to be cutting a variety of metals, I am going to leave this tip on here. This is a little standoff. It's supposed to give us about a 1/16 of an inch offset from the surface of our cutting material. So that's what we're going to do because we can use this as a drag tip, but only on 2 to 3 millimeter material, and we're going to be cutting a bunch of stuff here. So I guess we go ahead and we can power it up and see what happens here. Well, that was very unexciting, and that's okay. We have a chart. I am going to put the settings up. All right, the way we're going to do this camera is going to be looking at what our settings are going to be on the machine. This camera is going to be looking at what we are going to be cutting. And we are also going to be putting down the thickness of our material, the PSI, and the amps. All right, first thing we're going to cut is some 035 35 thousandths. We are currently at 55 psi and 25 amps. So there's the front, there's the back. We're going to have to take a look and see, is this what we normally get on the back of that? Can we just chisel that off? I don't know. Okay, it does not just chisel off of there. So, just for fun. Cutting at a slow speed results in significant, soft, porous dross, is what our manual says. Do we have minimal, easy to clean dross? I don't know that I'd call that easy to clean. Let's see if we pick up our cut speed. Okay, we got no problem cutting that fast. Not totally taken away, but we have minimized the amount of dross that we have on the back of that. So that is 035 steel. We're just going to continue plugging along here. 046. This is 1018 because that's what the invoice says. Let's see, 046. Yeah, we should be between 25 and 30. So just for fun, let's put it up to 30. That was some 118, but let's be honest here. I don't really have a really good way to hold that. Ow. I didn't really have a good lip, like a wide enough space to hold that. I really don't have a lot of area where it's only just one thickness of steel. So that's kind of an anomaly. Let's go do some. This says 138. Now, one of the other things, the issues that is coming up here is that for me, it is difficult to tell, do I have the proper angle? I'm attempting to hold this straight up and down. 138 thou, 3.5 millimeter, 55 psi. It says 40 amps. I'll tell you what that noise was when I moved my shoulder like that here in a little bit. what I have is an inconsistent cut there. Now part of it could be because of my speed, part of it could be because of my angle, part of it could be because it's not a smooth, continuous cut. Is that better or worse? I feel like we're at the doctor's office. Which one do you prefer, 1 or 2? 1 or 2? That looks pretty gloppy. So the manual says that that could be the result of a too fast cutting speed. So what we're going to do, flip it over. We're going to try to slow down. Let's see how we do here. Well, that did not seem to be better. Haha, of course. All right, we're up to 0.243, quarter inch. It's just got a little bit of rust on it. Let's just see what we can do here. We are at 60 psi, 45 amps. Okay, and I am on the flat, ugly part of the learning curve right now. Just trying to figure out what I can and can't get away with. That was faster. Now that stuff comes off of there pretty easy. Now you can see where I bumped, because the piece of metal I was using as a straight edge is kind of right on the edge of this, right on the edge of that, and that's where I bumped over on that. But yeah, that's all right. All right, let's have some more fun. 361 thousandths. It's 9.1 mil. This ought to be fun. 3/4 inch steel plate, 75 PSI, 60 amps. This is supposed to be what it's designed to do. So let's see if the operator can get out of the way enough for this thing to actually do its thing. Now there's quite a bit of ugly there. But we are going through. And let's see. Yeah, that comes off of there pretty easy. Give that another shot. Hey, if you stand on that really hot metal with your boot, it makes a sizzling noise, and now the whole room smells like burnt rubber. So you can, I don't know if you can tell that or not, there's a bit of a downward slant to that. That could be me. That could be just what happens when you're trying to cut through 3/4 inch. That's the piece we're cutting off. This is the piece that we are cutting. Again, we got a little bit of a slope. Got goop on the back. That easily knocks off of there. Am I happy? Well, heck yeah, I'm happy. Imagine how hot that is. All right, now we're going to do some cutting on aluminum. This is, let's see, this is 027, also known as a .685 if you're in the millimetrics. 55 PSI, we're at 20 amps. Yeah, fast cuts. That'll easily come off of there. That's the side we're cutting on. That's the back side. This is 1/16 inch. This is the flat bar that you'll get at your local big box store. This is, according to the website, this is like 6063. Is that what we're thinking? Yeah, 6063. A little icky, but my technique was probably poor. This is some 6061 aluminum plate. This is 0.063. That's 1.6 in the millimetrics. I should actually be on 30 on this. Now there is a weird discrepancy between what the knob says and what the readout says. If you go by the knob, we're at, I don't know, 33 or 34. Now, is that the way aluminum is? I don't know. If you know, tell us. Impart your wisdom upon the masses. That actually looks better when we slowed it down. There's the cut side. This will be a little fun. This is a piece of 3003 diamond tread plate. Diamond plate. And the thickness goes from 60 to 100 thou. So let's see what kind of fun this is. 55 psi, and we are at 30 amps. There's the cut edge. Not too bad. Let's go aluminum bar stock. This is 243. So 1/4 inch, 6061. Halfway through the cut, realized I probably should have changed my settings. Yeah, that's oogie looking. So that was on the previous settings. What we should be at is 60 psi and 45. Is that better? Not a lot. Is it a technique thing? I don't know. Let's see. Let's go faster. Apparently speed is it. Because that's not too bad. 6061, half inch, 75 psi, 60. So we're gonna max it out here because 75 is the max rated psi. Yeah, it doesn't look so hot again, does it? All right, we're back the next day. Where are we at? 3/4 inch aluminum. We don't know the flavor of this. Let's make sure we are on. $75 and $60 because our chart says, yep, $75 and $60. This is another max cut. We are at a different camera angle, and let's see what this is like. Yeah, it's ugly. All right, well, that was kind of fun. You can see we do have quite the angle on our cut. You can see, first of all, well, you can't see it, but it's really still pretty hot. A really ragged cut, but it's a cut nonetheless. So now let's have some more fun with a different type. I don't have a lot of this, but we're going to cut some stainless. This is, what is this, 321 stainless steel, and this is of the 30 thousandths variety. We get back in. We're back down, we're at 55 PSI and 25 amps per the chart. And yeah, if you can really see the sugaring up on this back side, we'll take a picture of this so we can look at it a little bit closer. Because we don't have any kind of backing gas on this, it does sugar up pretty bad. Let's try some. What does this say? This says 5510. Are we still at the zip? We're still at, this is 040, this is 1 millimeter, 55 PSI, 25 amps still. That is actually surprisingly clean. Like almost nothing. All right, now we're up to, this is T304, and we're at 87 thou as I kick the camera again. 55 PSI, we should be at 30 amps for this. We'll take a look-see. Yeah, that's not bad. Again, you've got sugaring on the back of that. Now that is more uglier. This is 380, 9.6 mil. We're at 70 PSI, 55 amps. Actually, that's at 60. So let's go to 55 because that's what the chart says. We're going too fast, we're going too slow, is the angle off? I don't know. Let's do that again. Pretty clean on the bottom. All right, let's get some weird stuff. All right, I've got 4 things left to cut. I have no idea how these are going to go. If they're going to cut any differently, if they're not going to cut any differently. This is a piece of 440. This is 0.525 thickness, which works out to 13.3 millimeter, 75 PSI, 60 amps. I don't know. Let's see. Got a big angle on that. All right, now I've got a piece of soft A2 tool steel. This is 513 thou, 75 psi, 60 amps. We're at max. I'm gonna give this a couple of cuts, see what it does. Well, that's kind of fun, little sparkles there at the end. Let's work on some technique a little more. And like most of our thicker cuts, we do have kind of an angle going on there. And that is not super easy to come off. Now, just for fun, I've got a smaller piece. This is a 282 piece of hardened A2. This is kind of a cool because this is a drop off of a wire EDM machine. So you can see just amazingly how precise EDM is electric discharge machining, where they actually use a wire to conduct electricity. I don't know a whole lot about it. I know it's like super cool, and how you get very, very, very thin parts, very detailed cut parts with an extremely thin kerf. So, all right, let's see. This is somewhere between 58 and 62 Rockwell. 282, our chart puts us at 65 and 50. There's 65, and here's 50. It'll be interesting to go back and look and see what our number actually does, because, arm, because I know that that is what my maximum is set at. I know that when I initiate the pilot arc, it's supposed to drop between 20 and 30, and then it's supposed to go somewhere where I'm set, and I don't know exactly where that's going to go. All right, A2 tool steel hardened. Let's see what we got here. Yeah, that's all right. Now this is the this is the true wild card here. I have absolutely no idea what this is going to do, if it's going to do anything. In fact, at the moment, I'm not exactly sure how I'm going to hold this. This is a piece of 050 CP2 titanium. CP means commercially pure titanium. I don't have any idea what it's going to do. We're going to go to 55 psi and 30, and that is what we call a wag. Okay, that was kind of ugly, as you can see. And to be fair, when you're starting to get into industrial applications and exotic metals, there's a really good chance that you are not going to be using. Oh wow, this is cool to the touch. You're not going to be using air. You're probably going to be using maybe an argon CO2 mixture, maybe nitrogen, and you're going to be using some other sort of gas to help you make a cleaner cut on that. Okay, we got a couple of more left to do. This is a piece of expanded steel. This is 030. This is just 30 thou. And we are down to 20 amps, 55 psi. Just like butter. This is a piece of 40 thou. And this might be a little smoky because this was actually painted. This is the only piece of other expanded that I had in this style or thickness. Just goes right through. And then we're going to do one more because there is a feature on here called 4T. We have been using 2T exclusively. 2T meaning that when I pull the trigger, it initiates the pilot arc for a set amount of time, and then if it senses continuity, we've completed this circuit, then it will initiate the cutting flame, or the cutting, I don't know what you call it, cone, lightsaber, I don't know, plasma arc. And then when you let go of that switch, you cease operation. What we're going to do, if you have a long cut, you go over here and you set this to 4T. And what happens is when I pull the trigger, it's going to initiate that pilot arc. When I let go, it's like cruise control. It is going to leave this circuit engaged so you can make a long cut without getting a tramp in your fun finger there. Then when we pull it again, it's kind of like tapping the off button on your cruise control, and then when you let it go, you close the circuit. So see, did you see how I had my finger off? Let's do that again. On. Okay. Did you see the downside of that? The downside of that being when you let go of that for a short period of time, your plasma arc is on and it will obliterate whatever you touch it to. So that is a 4T as opposed to a 2T or a 2T or a 2T. All right, that was fun. What did we learn? Learned a couple of different things. Practice helps. This is the first time I've ever run a handheld plasma cutter. That's not true. I did take a safety update course at the manufactory, and I'm pretty sure I ran maybe one cut, maybe two, because we had people in there who had almost zero experience with anything. And I thought that they were probably going to get a bigger bang for their buck by doing that. And I wasn't there to learn how to plasma cut. I was there to learn how to set the plasma cutter up so I could use it to run on the CNC table. So practice is going to help. Setup is going to help. The way that I was set up, because I'm trying to film for you guys and gals, and the way that I was set up is not ideal for learning because I could not see the direction of my flame, for lack of a better word. You're supposed to be able to tell if you have the correct work angle with your torch by how the flame comes out here. Is it coming out like this, or is it coming out like this? And if I can't see that, then I don't really have a good idea on what I'm doing. So that's something that we will change as we do this more and more. Some thicknesses cut better than others, and experimentation is going to be the key. Keeping your air dry is a big deal. I'll show a picture of you. I think I've probably already worn out my first tip. You'll see it's no longer circular. It is oblongular, and that is know the gooder. So we'll probably go ahead and replace the tip on that, and we'll go in search of, you can find cheap consumables, but they probably perform like cheap consumables. So check with the manufacturer, see who manufactures the particular torch that you have, and you may be able to find a supplier of OEM parts supplier. I don't know, I haven't really looked that much, but I know sometimes prices can vary greatly. And who you bought your plasma torch from, in this case it's PrimeWeld, they may be the best place in the world we live in right now, which of course is supply chain, because you can have a great price, but if it's out of stock, nobody cares. So I'll put some pictures up here at the end with metal thicknesses, what our cut settings were on that, and the result of that. I don't know if that'll help you guys or not. Like I said, my technique is probably la saccage, as the French would say. And so, take my results with, a grain of salt. If you're an old hand and you've been doing this a while, your results are going to be much better than mine are, because I don't really know what I'm doing. So anyways, that is the PrimeWeld CUT 60. That is run on 220 volts. And I'm not, they're not giving me anything to do this. This is me. I'm very, very happy with the 225. I love that welder. I've been exceedingly happy with that welder, and that was one of the reasons why I didn't really hesitate to purchase this when we started getting projects that we might need this capability for. So anyways, you guys have a great weekend. If I can do it, you can do it. If you got comments, put them in the comments section down beneath the sermon notes. If you found this entertaining or educational or some mix of the two, give us a thumbs up. Hit the subscribe button. Hit the little bell so you can be alerted the next time that I do, something stupid in the shop like this. Anyways, you guys have a great weekend. Cheers. Thanks for taking the time out of your day to spend it here with me. Hope you enjoyed this video. Here's one that you might enjoy as well. If you're not already subscribed, be sure to hit that button, hit the bell next to it so that you get a notification when we drop a new video. If you got comments, put them down beneath the sermon notes. And remember, if I can do it, you can do it. You guys have a great weekend. Cheers.